Note 6.2 example 13 is another right triangle trig application problem. So we are told that a diagonal path through a rectangular park is 600 feet long. And we're told that one side of the park measures 350 feet. And we're asked to find how long the other side of the park is. So once again, let's start by drawing a diagram. So since the park is rectangular, I will draw a rectangle. And then we're told that a diagonal path through the park, so I will draw a diagonal path through the park, is 600 feet. So I will label the diagonal's length as 600 feet. And one side of the park measures 350 feet. It does not matter which side you label as 350 feet. Either one will work. And it's a right triangle. I've created a right triangle because we know this is rectangle. So we want to know how long the other side of the park is. I will call that x. That's the unknown length. And now we can use Pythagorean theorem. So we can say that x squared plus 350 squared, so the sum of the lengths of the legs of the right triangle, is equal to the square of the hypotenuse, so that's 600 squared. So this turns out to be x squared plus, it's 122,500 is equal to 600 squared is 360,000. I'll subtract the constant from both sides. So x squared is equal to, turns out to be 237,500. And now we can take the square root of both sides. And if you enter that in your calculator, you'll find out that it's 487.3 feet. So the length of the other side is 487.3 feet. Okay, in part B, we're asked to find what angle does the diagonal path make with the side whose length you found in part A. So I'm going to label that angle. So the diagonal path creates this angle theta. So this is the diagonal path with the side we just found. So that's the angle we're interested in finding. So now we're going to go ahead and find that angle. So once again, we're going to use a trig ratio. So I'm going to label the triangle relative to the angle theta. So the diagonal is actually the hypotenuse. The 350-foot side is the opposite relative to angle theta, and the side we found is the adjacent. So in these types of problems, you're better off using the given length, so the 600 feet and the 350 feet, rather than the rounded value. So I am going to focus on the trig ratio that has to do with the opposite and hypotenuse, since those are the given values. So with SOHCAHTOA, the ratio that has to do with the opposite and the hypotenuse is going to be sine. So we're going to say that sine of theta is the length of the opposite side, which is 350 over the length of the hypotenuse. And then to find theta, take sine inverse of both sides. So it would be sine inverse of 350 over 600. You could simplify 350 over 600, but we don't really need to because it's an intermediate calculation. And when you enter that into your calculator and make sure you're in degree mode, you'll find that the angle is 35.7 degrees, or if you're in radian mode, it would be 0.623 radians. So this question doesn't specify the measurement for the angle, the units, so you could do either one. So the angle measures 35.7 degrees.